Welcome back. I'm Megha, and today we're spending some time with one of those questions that feels almost impossible to outgrow. Are we alone in the universe? It's a question that lives in science, but also in imagination. You can ask it as an astronomer, looking through telescope data. Or you can ask it as an ordinary person, standing outside at night, looking up and thinking, surely this cannot all be just for us. And once you begin asking it, the question opens into a dozen others. If life exists elsewhere, what kind of life is it? Simple? Intelligent? Ancient? Is it close enough that we might find signs of it? Or are the distances so vast that two living worlds could exist and never know about each other? And then there's the newer layer to all of this. If AI is changing how we search, analyze, and interpret enormous amounts of data, could it actually help us find life beyond Earth sooner? To explore all of that, I'm joined by Dr. Nesan, astrophysicist and researcher, whose work focuses on planetary systems, habitability, and the broader search for life in the cosmos. Dr. Nesan, thank you for being here.
Thank you, Megha. It's good to be here. This is one of those questions where even the attempt to answer it becomes meaningful.
That's exactly how it feels. Even before we know the answer, the question already changes the way we think. So let's begin with the most honest version of it. Right now, scientifically, when someone asks, "Are we alone in the universe?" what is the answer?
The most honest answer is still, we do not know. And I think it matters to start there, because people sometimes feel disappointed by uncertainty. But uncertainty is actually where good science begins. We are not at the stage where we can say yes, and we are not at the stage where we can say no. What we can say is that the universe appears to contain an extraordinary number of opportunities for life. There are vast numbers of stars, vast numbers of planets, and many environments that seem, at least in principle, capable of supporting liquid water and chemistry complex enough to matter. So if you ask for my scientific instinct, I would say it seems unlikely that life happened only once. But instinct is not evidence, and science has to stay loyal to evidence.
That distinction is so important because sometimes public conversation jumps straight from "the universe is huge" to "so aliens must be everywhere." And that's not really the same thing.
No, it isn't. Large numbers increase possibility, but they do not erase complexity. We still don't fully understand how life began, even here on Earth. So while the scale of the universe suggests that life elsewhere is plausible, perhaps even likely, the actual path from chemistry to biology may still be rare, fragile, or dependent on circumstances we don't yet understand.
So when people hear alien life, their minds usually go to intelligent civilizations, spacecraft, signals, some version of first contact. But from a scientific point of view, what are we actually more likely to find first?
Almost certainly something simple. If life is discovered in the near or medium term, it is much more likely to be microbial life than intelligent life. That could mean ancient fossil-like traces on Mars, or chemical evidence from the oceans beneath the ice of Europa or Enceladus, or atmospheric biosignatures on exoplanets that suggest living processes. And although that sounds less dramatic than meeting a civilization, it would be one of the biggest discoveries in human history. Because the first real threshold is not, are there alien engineers? The first threshold is, did biology happen more than once? If the answer to that is yes, then the universe becomes a very different place.
That's such a good way to frame it. The first breakthrough is not necessarily about intelligence. It's about whether life itself is a cosmic pattern rather than a one-time event.
Exactly. If we found even microbial life somewhere else, it would tell us that Earth is not the only place where matter became animate, organized, self-sustaining. That would profoundly reshape biology, philosophy, even the emotional way we understand our place in existence.
And yet we haven't found that, not definitively. Which brings us to the famous question. If the universe is so full of stars and planets, why is it still so quiet?
That's the heart of what is often called the Fermi Paradox. If life, especially intelligent life, should be common, then why don't we see more obvious evidence?
There are many possible explanations, and one reason the question remains so fascinating is that several of them could be true at once. It may be that simple life is fairly common, but intelligent technological life is rare. It may be that civilizations arise but don't last long enough to overlap meaningfully with one another. It may be that interstellar travel is so difficult that even advanced species mostly remain local. It may be that we're listening for the wrong things, or that signals don't last, or that advanced civilizations become less detectable, not more. And perhaps most humbling of all, we may simply be early, or inexperienced, or both.
The "we may simply be early" idea always gives me pause, because human beings often speak as if we've been searching the universe for ages, but in reality, our technological search has barely begun.
That's right. In cosmic terms, it has barely started. Radio astronomy is recent. Exoplanet science is recent. The ability to analyze atmospheres of distant planets in meaningful ways is extremely recent. There is a temptation to think silence means absence, but often silence just means our instruments, timescale, or assumptions are limited.
That feels true in a lot of areas, actually. Silence is not always emptiness. Sometimes it's just distance, or weakness of signal, or the fact that you don't yet know how to listen.
Yes, and the universe, unfortunately, does not simplify itself for our convenience.
It rarely does. Let's talk about where the search is actually happening. When scientists say we're looking for life, where are the most promising places right now?
There are a few categories. One is our own solar system. Mars remains important because it may preserve evidence of ancient habitable environments and perhaps ancient life. Europa and Enceladus are especially compelling because they seem to have subsurface oceans, internal energy sources, and chemistry that may be favorable to life.
Another category is exoplanets, planets around other stars. We are increasingly able to detect them, estimate their sizes and temperatures, and in some cases, study their atmospheres. That opens the possibility of looking for biosignatures, meaning combinations of gases or atmospheric patterns that are hard to explain without biological activity. The third area is the search for technosignatures, signals or artifacts that might indicate technological civilization. That includes radio signals, unusual light patterns, or other anomalies. Each of these paths asks a slightly different question. One asks whether life ever began. Another asks whether life is active now. And another asks whether intelligence ever became technological.
And all three are extraordinary in different ways. With Mars, I think people often imagine finding something alive today. But even evidence that life existed a long time ago would still be monumental.
Absolutely. Ancient life would still answer a central question. If Mars, for example, once hosted life independently of Earth, then we would know that biology can emerge on more than one world, even within a single solar system. That would make the case for a living universe much stronger.
And if we look farther out, to exoplanets, what are scientists really hoping to detect? Because I think biosignature is one of those terms people hear a lot, but may not fully picture.
That's fair. A biosignature is not a little flag that says, life here. It is usually a pattern, especially in atmospheric chemistry, that may suggest biological activity. For instance, if a planet's atmosphere contains gases that shouldn't coexist for long unless something is constantly replenishing them, that can be interesting. On Earth, life strongly affects the atmosphere. So the broader idea is, Can we detect signs of chemical disequilibrium that are more plausibly explained by living processes than by geology alone? But this is delicate work. Biosignatures are not easy to interpret. Nature can produce misleading signals. So even if we find something promising, it usually takes a lot of caution before calling it evidence of life.
So this is not a field where scientists rush to announce cosmic neighbors after one strange data point.
Ideally, no. Science is at its best when it resists that temptation.
That's reassuring. Let me ask the timeline question, even though I know scientists never love timeline questions. Are we talking decades? A century? Longer? When do you think humanity might actually get compelling evidence of life beyond Earth?
My cautious view is that meaningful evidence of simple life could plausibly emerge within this century, perhaps sooner. That may come from our solar system, or from atmospheric observations of exoplanets, or from some combination of missions and telescope capabilities we are developing now. Intelligent life is much harder to predict. We may go a very long time without a confirmed technosignature, or we may find a puzzling signal unexpectedly. That uncertainty is real. But if you ask me whether the next 100 years could contain a major turning point in the search for life, I would say yes. I think that is entirely possible.
And possible in this context already feels huge, because the question is so old. Human beings have asked it for so long.
Yes. Across cultures and centuries, we have kept returning to it. Long before modern astronomy, people looked at the sky and wondered whether existence was shared. What changed is that now, for the first time, we have methods. Imperfect methods, but real ones.
Let's turn to the reverse possibility. We often talk about humanity finding aliens. But what about aliens finding Earth first? Is that realistic, or mostly science fiction framing?
In principle, it is possible. Earth has been emitting radio and other electromagnetic signatures for over a century. A sufficiently capable civilization in the right place could, in theory, detect signs that this planet hosts technology. But practically, space is vast and signals fade. So while it is not impossible, it is probably less immediate than popular imagination suggests. And if we move from detection to physical arrival, then you have to deal with the problem of interstellar distance, which is formidable. Even for advanced civilizations, the universe does not make travel easy.
So perhaps no need to panic every time someone sees an odd light in the sky.
Probably not. Though I would still recommend curiosity over panic as a general life policy.
That's solid advice in most situations. Now I want to bring in AI, because this is where the conversation becomes especially contemporary. Astronomy already produces enormous amounts of data. Could AI materially change the search for life?
I think it already is, and it will continue to. Modern astronomy is overwhelmed, in a good way, by data. Telescopes, surveys, spectroscopic instruments, imaging systems, they generate volumes of information that are difficult for human teams to examine line by line. AI is useful because it can classify patterns, identify anomalies, prioritize targets, reduce noise, and help us sort the interesting from the ordinary. In exoplanet work, for example, AI can assist in detecting subtle signatures in starlight that may indicate planets. It can help classify atmospheric spectra. It can also assist in searching archival data for patterns humans may have missed. So in that sense, AI expands our ability to pay attention.
That phrase is beautiful, actually. It expands our ability to pay attention. Because that's what a lot of science is, in a way. Not magic, not certainty, just better forms of attention.
Yes, better attention and better filtering. The challenge is that the universe produces a lot of ordinary complexity, and hidden somewhere inside it may be the rare things that matter most.
And AI can help with that, but I assume it also brings new risks.
Certainly. AI is very good at finding patterns, but not every pattern is meaningful. It can amplify bias if trained poorly. It can prioritize what looks statistically interesting rather than what is physically significant. And if scientists become too trusting of the tool, they may mistake suggestive output for genuine understanding. So I would say AI accelerates the search, but it does not replace judgment. It can point. It cannot, on its own, interpret reality responsibly.
So AI might help us notice a possible signal, but then science still has to do the slow work of doubt.
Exactly. In many cases, discovery begins not with celebration, but with skepticism. You ask, is the instrument behaving correctly? Is there contamination? Is there a simpler explanation? Can anyone else reproduce this? If AI becomes part of the search for life, then the best outcome is not automated certainty. It is better partnership between computational tools and careful human reasoning.
Do you think AI could help most on the biosignature side, the technosignature side, or both?
Both, but perhaps in different ways. For biosignatures, AI is very promising because atmospheric interpretation and planetary classification involve huge datasets and subtle patterns. For technosignatures, AI can help scan wide parameter spaces and identify anomalies in signals or observations that merit deeper study. But in both cases, I think the deeper value is not just speed, it's scale. AI lets us search more broadly and more systematically than we otherwise could.
Which may matter a great deal if the thing we're looking for is rare, ambiguous, or easily buried in noise.
Yes, if evidence is sparse, then widening the search intelligently is crucial.
I want to pause on something more philosophical. Let's imagine that tomorrow we get an answer. Not necessarily a Hollywood-style answer. Maybe it's microbial life under the ice of Europa. Or maybe it's a highly credible signal from elsewhere. How does humanity change after that?
If it's microbial life, the change may be profound but somewhat gradual. Biology would change immediately as a science. Our theories about life's emergence, adaptability, and distribution would have to expand. Philosophically, the effect would be immense. Life would no longer be understood as something that happened only once, here. If it's intelligent life, even in the form of a signal, the impact would likely be immediate and global. It would touch religion, politics, culture, identity, and language. It would become one of those rare moments when humanity is forced to reinterpret itself all at once. Because the discovery would not just tell us something about them, it would tell us something about us, about how unique we are or are not, about whether intelligence is a common branch of evolution or a rare accident.
And maybe about whether maturity is common too, which is a slightly more worrying thought.
Yes, if we ever detect another civilization, one of the silent questions in the background will be, how long did they last, and what did they become?
That's such a haunting idea. The search for aliens is also, quietly, a search for possible futures.
I think that's true. Sometimes when we ask whether there are others out there, we are also asking whether intelligence can survive itself.
That lands hard. Because for all the wonder in this question, there's also vulnerability. What if civilizations are common, but brief? What if the silence means not emptiness, but fragility?
That is one interpretation. We do not know if it is correct, but it is one reason the question remains so emotionally powerful. It forces us to look outward and inward at the same time.
Do you think that's why this topic fascinates people even outside science? Because it doesn't stay external. It becomes personal very quickly.
Yes. The question sounds astronomical, but it becomes existential almost immediately. Are we alone? Are we rare? Are we ordinary? Is life something the universe tends toward, or did it happen here by astonishing accident? And beneath all of that, there is another question. What kind of universe do we inhabit? One that is full of becoming? Or one where consciousness is almost unbearably scarce?
That may be why people never stop asking. Before we close, I want your personal view. Not the careful official version, but your own. When you look ahead 100 years, what do you think is most likely? Humans find microbial life? A biosignature? A signal? Nothing?
My personal guess is that within the next 100 years, humanity has a decent chance of finding compelling evidence of life, most likely simple life, or at least strong biosignatures that become harder and harder to dismiss. I am less confident about intelligent life. That may remain elusive for much longer. But I would not be surprised if this century becomes the era in which the question changes from pure speculation to evidence-based debate. That alone would be historic.
It really would. There's something moving about the idea that for thousands of years, human beings looked at the same sky and asked the same question, and that we may be among the generations that finally begin to answer it.
Yes. And whatever the answer turns out to be, it will reshape us. If life is common, we will have to learn humility in a new way. If life is rare, then we may have to learn responsibility in a new way. Either way, the answer will ask something of us.
That may be the perfect place to end. Dr. Nesan, thank you. This was thoughtful, unsettling, hopeful, all the things a good conversation about the universe should be.
Thank you, Megha. I enjoyed it.
And thank you for listening. Whether we are alone or not, the search itself says something beautiful about us, that we are a species willing to look into the dark, ask difficult questions, and keep listening. Until next time, keep looking up.